Hi, everyone. Okay, this is chapter 6. This is where we're going to go through mechanical advantage and using simple machines. AMA stands for actual mechanical advantage. It is the ratio of the output force to the input force. So if you see FO stands for output force, FI stands for input force. Ideal mechanical advantage, IMA, is the ratio of the input arm to the output arm. And that would be SI would be the input arm's length, and SO would be the output arm's length. And therefore, FO over FI equals SI over SO. A typical car jack has an AMA of 30. If you push down with 20 newtons of force, how much does the jack push up with? So AMA is 30. And FO is what we're looking for, and FI is 20. And when you do the math, you get 600 newtons. Notice there's no units on AMA because AMA and IMA are ratios, so the newtons cancel out. Okay, so if you push down with 20 newtons of force, you're getting 600 newtons of force from the jack. That's why it works so well. So if you push down on the handle 20 centimeters, how much did the jack rise? So you put in the other formula, the FO over FI equals SI over SO, and you end up getting 0.66 centimeters. So if you push down the handle with 20 centimeters, it only goes up 0.66 centimeters. In a real machine, the AMA is less than the IMA. Okay, so it's good to know. All right, efficiency is how effective the energy is being used. So efficiency is the output work over the input work, or the AMA over the IMA. And percent efficiency is output over input times 100%. A pulley can lift a 20 kilogram load with an input force of 65 newtons. The load is lifted 30 centimeters when the input pulls the pulley rope 150 centimeters. Find IMA, AMA, percent efficiency. And those are the formulas you're going to be using. So the IMA is SI over SO, and SI is the input. So you pulled down with 150 centimeters of rope, but it went up 30 centimeters. Therefore, your IMA is 5. Your AMA is your output force over your input force. The output force is the weight you're moving, which is 20 kilograms times gravity. Because remember, force is measured in newtons, and newtons is mass times acceleration. And then the input force is 65 newtons. And your AMA comes out to be 3.0. And remember what we said? IMA is always larger than AMA. Percent efficiency, you have 3 over 5 times 100. You have 60% efficient on the pulley system. You are going to get a question like this on your test, so make sure you know how to do it. Number 2, calculate the efficiency of an electrical motor which uses 300 watts of power to get an output of 1/4 horsepower. All right, so first thing we have is percent efficiency is output over input times 100. We have watts and we have horsepower. So we need to convert the horsepower into watts first, all right, because we want watts and watts. Otherwise, your units will be all just a mess. So 0.25 horsepower times 746 watts per horsepower, which is in the front of your book, the conversion, divided by the 300 watt power. You get times 100 gives you 62% efficiency. Okay, let's take a wedge. All right, a wedge is used to split wood, different things like that. The SI of the wedge is the length of the wedge. The SO is the width at the top. So find the IMA of a wedge that's 20 centimeters long and 10 centimeters at the top, and you get an IMA of 2.0. The IMA of a screw. Now, a screw is an inclined plane wrapped around a cylinder. So IMA equals SI over SO. SI is 2 pi r, okay, over P. And P is pitch. When you buy screws, it tells you what the pitch is on the screw. It tells you if it's a quick pitch or a small pitch. And it says, what is the IMA of the screw? That's 2.6 millimeters in diameter and has a pitch of 0.4 millimeters. Now, if you're using millimeters and millimeters, you don't have to convert to meters, all right? Because the millimeters and millimeters will cancel out, so you can just leave them like that. So you get 2 pi 1.3, all right, because 1.3 is the radius of the screw, all right? Because when you get a package of screws, they tell you what the diameter is, all right, the width. And the pitch is 0.4, and you end up getting an IMA of 20.42. So what that basically means is that for every pound of force you use to screw that screw into the wood, it's doing 20 pounds of work, okay? IMA of a lever. RO is the distance from the fulcrum to the load you're lifting, and RI is the distance from the fulcrum to where you're pushing down on it. All right, a driver has a stuck lug nut. How much force will he exert if he stands on the end of his tire iron? The length of the tire iron is 40 centimeters, the radius of the lug nut is 1 centimeter, and the man's mass is 120 kilograms. So we're looking at FO over FI equals RI over RO. So FO is the output force. 120 kilograms times gravity is the input force. That's a person standing on the bar. And then 40 centimeters is the length of the tire iron, and 1 centimeter is the radius of the lug nut. Okay? And you get 47,088 newtons of output force. All right? And if you ever get a lug nut that won't come off, if you could put a pipe around the tire iron to increase the radius, the length of the arm, and that would then give you even more force. Pulley systems. The IMA of a pulley system is equal to the number of strands that support the movable mass. Note, direction change does not count. IMA equals SI over SO. S is the amount of rope pulled. All right. AMA equals FO over FI. So if we look here, selection number 1, we have a 100 Newton force, and you have to pull 100 with 100 newtons to lift this. This is just a directional change. All right. So pulley system number 1 is just a directional change. There's no mechanical advantage. Okay. Number 2, you have 2 lines here. All right. And then this is your directional change. Okay. Because you're pulling it up and you're pulling down. You don't count this one. So you have these 2 strands. So this is 2 strands, so it's a 2-to-1 relationship. So if I want to lift 100 Newton force, I need to pull with 50 newtons. If I want to lift it 10 centimeters, I have to pull it with 20 centimeters long. Here we have 3. There's 3 lines here. It's a 3-to-1 ratio. As you can see, the numbers change accordingly. And here, this is a 4-to-1 ratio, and exactly the same thing. All right, here you pull 4 times as far to lift it the same amount. And the hydraulic press. A press is IMA equals SI over SO equals the area over the area. Okay. Now, this is how car lifts work when you take it into the garage and they lift your car up. All right. Your car sits over here. All right. This gets pushed down and it lifts up your car. Okay. And basically, it's just the fluid is hydraulic fluid and applies the pressure, okay? So that's basically how those work. So you can figure out what the mechanical advantage is of that. And this mechanical analogy is like lifting the stone with a longer lever arm, okay? That's basically what you're doing. So they pump pressure into this piston. It pushes the piston down. That piston pushes the fluid and then lifts your car, okay?